isn't it time that we start to look at plotting and visualizing things? Plotting, yeah. We know from before, import numpy as np and import pandas as pd. One thing we always know as well is import, or what's new with plotting, is import matplotlib.pyplot as plt. Now this is a new library we'll just start to look into, and within here maybe we have we can start with lists, list A, of course, can maybe be 0, 1, 2, 3, 4, and B is equal to 1, 2, 5, 9, 12. So basic lists of integers. So if we plt.plot A B, I think we should get, then we actually plot out Python lists. But this we can also do with numpy arrays, with pandas data frames, and I'll just briefly just show how you can do this. And this is what they call like the pyplot API. But if we go into help and into Matplotlib here, we can go to, I guess, tutorials. Here is a basic usage and pyplot tutorial. We can first like look into the pyplot. That's like using plt.plot and plt.ylabel, some numbers, and then you see here, and plt.show. Here you see it with the lists as we did, and here you see it with dots. We can maybe test this ourselves, and here we even set plt two lists and some string as well. If you guys have played with from Matplotlib, then you sort of know this. It's red circles. So this O is circle. If we change it to a minus, then it would be red dash. So then we get the dashed line. If we put in, I guess, star here, see here, star, then we get stars. So there's many ways of sort of marking these dots as well. But this is like the way we use this so-called pyplot API towards Matplotlib. But there's also, if we go into basic usage here, there's something called a figure and something called an axis. But if you want to get deeper into what all of it is, then basically the figure is like the empty canvas, and then axes are like the x and the y axis. That's one set of axes. You can also subplots and create multiple axes. So, and here you see already code that you can just take and sort of take that code and try to fit it to your plotting. And that's sort of how we usually try and fail and move forward with plotting. Let's just play a bit more here. We can, we know x equals npy.lin space from the calculation. So we can maybe take from 1 to 10 with 1000 data points. We like thousands of data points, don't we? And y is say x times x. Let's make it more exciting. Plus 2. So now we've set in a bias. We want to negate this because this quickly becomes quite big. Minus 10x. Yeah, sure. 10 times x. So now if we plt.plot x and y, we get this. So now we get this. Oh, nice plot. We can also add color, keyword arguments. Color equals red, I think. Then we get the red here. So we can also use this notation and other notations. There's so many different types of notations we can use here. Say we even had so and now we're plotting with not lists, but with ND arrays from, or one-dimensional ND arrays from NumPy. Let's also jump into our collections, since we have already played a bit with random data. I guess we can even take this. So that's the data frame we created with random data, like this here, but with a date time index. And say that we want to plot, if we just plt plot and df and a, then we should plot this, and then you see that we get a time time on the x-axis, because it looks at the series that it returns and sees, oh, this is a date time index, and it automatically sets it up to that. So that's sort of a super quick introduction into Matplotlib, super quick. But if you want to make prettier figures, then just go into Matplotlib and try to I usually go into examples here. There's so many examples here. So we can go into and try to figure out what you are trying to visualize, and just look into here and see if you can find the thing that most relates to the thing that you're trying to visualize. Here you see even contour plots, like more complex plotting, and it's so good to have these different reference drawings to look at. So say that you, I think this is of importance, error bars, and in many directions. We can just copy paste this and take it into plotting and paste it in here, and you see here, imports NumPy and import this, and it can just plot it, and then we see that we plot this, and you can try to sort of get this to fitted to your application. And you see here we use fig, plt.figure, and then we then it plots error bars, and adds a legend as well. So you can also add, if you put in labels, and then you can also add a legend. So it's quite it's quite useful, this. Since we're on learning plotting, I also want to mention two other. Seaborn. There's also something called Seaborn. So basically seaborn.pydata.org, or just use your search engine and find it. Let's see here, we can do the same thing here. It's galleries. Say we want something even this, and here's even prettier plotting and figures and creating these figures. Say we would take this, and here you see, it's already the code here, and this time it's import Seaborn as SNNs, but Seaborn is basically built on top of Matplotlib again. So there's so much going on here. So if we can split this up, so we take out, we don't need to have, import Seaborn as SNS. Then we can, inside SNS, there are ready-made datasets. We can take out the dataset MPG, I guess it's miles per gallon, and then we can, and we take it out as a pandas data frame. I can take this out as well, so we can have a look. MPG, it's actually a pandas data frame. So you see here, MPG, cylinder, displacement, horsepower, weight, acceleration, model year, origin, and also the name of the, so it's basically a lot of specs of many different cars. And SNN can do a rel plot, I guess a relational plot or something, where x-axis is horsepower, y-axis is miles per gallon, the hue is the origin, where it comes from. So basically it's the USA, Europe, or Asia. Size equals the weight of the markers. And then some scaling, and then alpha. If we add alpha, then it's transparency. Palette is muted. and data equals the data frame. So, and then we can do this, and what we get out of it is a beautiful plotting where the size is the size of the weight of the car is the size, and where it comes from is the color, and you see horsepower versus miles per gallon, and as we usually think, Japan and Europe has the smallest sort of engine size, and also the least horsepower, but they are also the most sort of fuel efficient cars, and while American cars are like famous for having big V8s and stuff like that, and they're not that fuel efficient, but they usually have a lot of horsepower, and at least within this data set. So this it's incredibly powerful what we can do with having a pandas data frame and having Seaborn or Matplotlib, or we can even go even deeper. But then I think we need to install a library. Let's see here. Then we need to kick up a prompt. Let's. I can take this prompt in. Window capture. So we can pip install Plotly. I love Plotly. And if you don't have the packages that you need, just pip install your packages. It's really easy. Oh, there we have Plotly installed, and then we can use something called Plotly Express. So basically import Plotly.express as px, and there's like this famous dataset from a data source called Gapminder. If you are familiar with Hans Rosling's work on population demography, this is an incredibly famous dataset, where inside, again, it's just a pandas data frame that we get from, we import Plotly Express as px, and within px there are some ready-made data sources, and we take the Gapminder dataset that's just installed when we install the library. So we just download it because it's such a famous dataset. And here you see Africa, the different years, what the life expectancies, what the population, what the GDP per capita, and then we have like ISO alpha, so basically the alphanumeric, the shorthand names for these countries, and say we just want to maybe filter it on by year. So if we set df, I think this is a bit new. If we filter it by, say, 1952, since that's the top year here, if we just do this, we just get a series that's true or false. But what we can do with this is we can, if we since this is a series of true and false, so it's true wherever we have 1952, we can call the df, but we only want the series where this comes true. And then we get only 1952, so it's a way we can filter out the pandas data frames. And this is something you get used to the more you work with pandas data frames, how to filter these, how to work with these. And you see then we go to, since we had 17,004 rows, but then we go back to only having 142 rows. So this is a way that we can filter this. But I'm just going to briefly just show how quickly we can get so much information. So this it's just px, and we do a scatter plot. We put in our df. X equals GDP per capita, Y is the life expectancy, and then animation frames, and we can animate by year, and the animation group is per country. The size of the bubbles is the population of the country, and the continent is the color, and also the hover name is country, and some making this logarithmic because countries are as countries are. But look at what the pretty thing we get out is, and this is a really famous plot from Hans Rosling when he had his TED Talks and did his population studies and presented it to like the World Economic Forum, and has really revolutionized and coined the term factfulness. And that's a term that's very interesting, because we can simulate now how population growth goes according to time, and we can use this to have a lot more information richness or factfulness about the world and about the dynamics and of the world. And if we can do the same thing to the industrial space by being able to use these things to inform us to do better decision making, or to be better in the way we work, I think it can be so much more worth it. And doing this, it's incredible. But just quickly, we can just go to Plotly, plotly.com, and here we have like docs, and take some time, and here we have even something called Plotly Dash, and what we do is we use something called Plotly Express. Let's see if we can find it here. Docs, graphing libraries here, and here we have Plotly Express. See here we have scatter plots, we have line plots, we have pie charts, and we do the same thing here. We just find something that's more fitting to us. We can even use on maps, doing graphical data on maps. PCA, this is dimensional reduction of data, so principal component regressions, where this is also a very famous dataset. It's called the iris dataset, where you can separate the different types of irises by the length and width of the flower, sepal, and petal. Really, when you get into machine learning and try to use maybe principal component to separate out these different species, because some of them are a bit hard to separate. When you look at the Virginica and versicolor, it can sometimes be a bit hard to separate out. But yeah, if we want this, you can just copy it over, take it to our plotting library, and plot it. We don't have to import Plotly Express, because that one we have already. So here, df, it's just the px and get the data, and we take the iris dataset. We have the features here, just set that into a list, and then we scatter matrix them with the data as the df. The dimensions are the features, and the colors are the species of the df. So if I can just Alt Shift, and then we can have a quick look at the data frame you see here, and then we can plot it. and then we get the same plot we get we got here, and that's how usually people work with plotting inside Python. And so a lot from just simply introducing Matplotlib to Seaborn to like advanced animations with Plotly. I'm sorry this is a lot, but I just wanted to introduce these three plotting libraries fairly quickly. But when you need more information, just do your own digging, try to figure out the plot that you need, and see where it goes, because it's so contextualized to whatever issue you have, and also some quickly filtering on data frames.